All right, so in this lesson, we're going to talk about the fundamental counting principle. And if you remember back in lesson 3, we talked about the probability of compound events. And that's where we used tree diagrams and we drew out a variety of possibilities, whether it was like the meat on a sandwich and the type of bread. And so we listed all the combinations of like white, wheat, and rye. And then we had ham and turkey coming off of that. And so it created all those options. And that's useful, but it's also really, really time consuming to have to draw out those tree diagrams, especially when you're maybe dealing with a lot of different combinations of something. So in the fundamental counting principle, it's meant to kind of make things easier for us to find both either the total number of combinations of something or the probability. And we're going to do that through multiplication. So we're going to use multiplication instead of tree diagrams to be able to find the total number of possible outcomes. But we will also use this to find probability as well. So looking at this first example, it says find the total number of outcomes when choosing from bike helmets that come in 3 colors and 2 styles. So just kind of going back here, I'm going to exit out of this because I can't show you, I can't write while I'm doing that. So if we had, let's say we had 3 colors and they were, green, red, and blue. And then 2 styles coming off of that. And then we would have, I don't know, let's say we have one style that has, we'll go with math theme, has minuses on it, and one style that has pluses, right? And so we look and see all the total combinations here that we have. So we could have a blue helmet that has minuses all over it, or we have a blue helmet that has pluses all over it. We could have a red helmet that has minuses or pluses all over it, and then a green helmet. So here we see the total number of combinations are 6. But there's a much, much easier way to get there instead of having to write out this tree diagram. All we have to do is just notice the total number of choices. And so we have, I didn't mean to draw that line there. So since we have 2 choices and 3 choices, we just multiply those together. 2 times 3, and that does give us 6. And so if you compare that to the tree diagram up here, 1, 2, 3, 4, 5, 6. There are a total of 6 outcomes that exist in this example that we've used through multiplication. So that's really all that you have to do with that. Is just a matter of multiplying the number of outcomes. All right, so let's get back to the pointer here and we'll move on to the next example. So there you see that there are 6 choices of helmets. All right, next example, 2 number cubes are rolled. What is the probability that the sum of the number cubes is 12? How likely is it that the sum would be 12? Well, first we have to know the total number of outcomes. So if we have the first dice that has 6 outcomes possible on it, right? A dice has 6 sides. And then our next roll, the dice still has 6 sides. We would multiply those 2 together. So the first thing we would need to know is that there are 36 outcomes. Now this is asking us in this question, what is the probability? So just saying that there are 36 outcomes doesn't answer that question. And plus we are concerned with how many of those would equal, when I roll these combinations, the first dice and the second dice, would I get a sum, remember that is addition, that adds, that would equal 12. So what 2 numbers would give us 12? Well, if you think about in that example, the dice would have to land on a 6 and a 6 for that to add up to 12. That is the only combination that works. No other combination will work in this example. So that means, you can see my answer here. We already came up with 36 total outcomes, but since 6 plus 6 is only one combination out of those 36, that is a 1 in 36 chance of rolling 2 numbers that have the sum of 12, which 1 out of 36 is not very likely to occur. So the odds, the probability of that occurring are not very likely. So using kind of some phrase like this, saying that it's not very likely when we don't see a very full fraction here is helpful. All right, and then we have, this is the last example, find the total number of outcomes when choosing a 4-letter password using only 5 letters that may each be used more than once. So what's going on here in this example is that you have a password, and that password has 4 spots in it, right? It says it's a 4-letter password, meaning that we don't use numbers, but all these spaces are occupied with a combination of letters. And it says that there are only 5 letters that can be in this password. So some questions you might see in the future will deal with like the entire alphabet, all 26 letters. This one only has 5. So there are, and since they can be used more than once, there are 5 letters that can go in the first spot. We can reuse any of those same letters. There can be 5 letters in the second spot, 5 letters in the third spot, and then 5 letters in the fourth spot. So then we just multiply those together, and then you'd get 25 from 5 times 5, and then 25 here, and we have to still multiply both of those together. 25 times 25 would give us the answer. And if I exit out of this and go to the next slide, we see our answer would be 625. That's what results from multiplying those two together. So like I said before, imagine having to do a tree diagram where there are 625 total options that you have to draw out. That's not really possible. So this is where the fundamental counting principle really shines, where it really comes in handy, because then we don't have to do those calculations. We don't have to draw out we have to do a calculation, but we don't have to draw out the whole tree diagram. It's a much simpler method of finding the total number of outcomes or finding the probability. So another thing to look at, since I wrote this as a fraction here, we found the total number of outcomes is 625. What is 1 over 625? That would be like the odds of guessing somebody's password. It's not very likely to occur, right? If you know anything about like putting passwords in for an email address, using more complex is better, because that way someone can't guess it. So that's really what you're going to be working through in this. Try to keep this fairly short this time, and then remember, we'll have some video conferences that you can tune in to if you have specific questions on the homework. So thanks for watching.